There are 1,500 billion stars out there right now with no home, no galaxy, no family, just floating alone in the darkness of space. And we just found them, all of them, in a single image. That is not a movie. That is not science fiction. That is what happened when the Euclid Space Telescope opened its eyes, and what it saw in those first few moments changed everything we thought we knew about the universe. Scientists are calling it a gold mine. Astronomers are losing sleep over the data, and one researcher, after seeing the results, said on camera, "This is the start of the adventure. Not the end, the start," meaning what we have seen so far is just the opening frame of a story so big, so deep, so shocking, that human beings may never fully understand it. So today we are going to go through everything. The launch, the first images, the jaw-dropping discoveries, the orphan stars, the invisible map of dark matter, the Einstein ring hiding in plain sight for over 100 years, and the one question that Euclid is slowly, terrifyingly beginning to answer: what is the universe actually made of? Sit down, because this is going to blow your mind. Let's start from the beginning. For decades, scientists have been haunted by a number. That number is 95. As in, 95% of the universe is invisible. You cannot see it, you cannot touch it, you cannot detect it with any normal instrument. It is just there, pulling things, pushing things, shaping everything. And we have absolutely no idea what it is. We gave it names to make ourselves feel better. We call the invisible stuff pulling galaxies together dark matter. And we call the mysterious force pushing the entire universe apart, faster and faster, like something is pressing on a gas pedal nobody can see. We call that dark energy. Together, dark matter and dark energy make up 95% of everything that exists. The remaining 5%, the stars, the planets, the galaxies, the black holes, your body, this screen you're watching on, all of that is just 5% of the universe. 5%. You're made of cosmic leftovers. And for all of human history, we have been completely blind to the other 95. That is why Euclid was built. Not just to take pretty pictures, but to solve the greatest mystery in all of science. To map the invisible. To trace the shape of what we cannot see. To finally answer, what is the dark universe and why does it exist? On July 1st, 2023, Europe launched that mission into space. A telescope called Euclid, named after the ancient Greek mathematician who defined the geometry of space itself. It blasted off on a SpaceX Falcon 9 rocket from Cape Canaveral, Florida, and traveled 1.5 million kilometers from Earth to a gravitational sweet spot, right next to where the James Webb Space Telescope lives. And it parked itself there, facing the cosmos. And then it opened its eyes. Now, before we get to what it saw, you need to understand what this telescope actually is, because Euclid is not like any telescope that has come before it. The Hubble Space Telescope is a legend, the James Webb is a revolution, but both of those telescopes have something in common. They look at a tiny piece of the sky. They zoom in deep, like a sniper rifle pointed at one precise spot. They are incredible at studying individual objects in extraordinary detail. Euclid is different. Euclid is a shotgun aimed at the universe. It carries a 600 megapixel camera, 600 megapixels. The camera on your phone is maybe 12, maybe 50 megapixels if you have a fancy one. Euclid's camera is 600. It also carries a near-infrared spectrometer and photometer, instruments that can read the chemical fingerprints of galaxies billions of light years away. And here's the key thing. Euclid can image an area of sky 175 times larger than Hubble with the same level of sharpness, 175 times the area. That is like having a camera that can take a photo as detailed as a microscope shot, but covering an entire football field instead of a single blade of grass. By the time Euclid finishes its primary mission in 2030, it will have mapped 1/3 of the entire sky. It will create the most accurate, most detailed, most comprehensive 3D map of the universe ever made, covering 2 billion galaxies across 10 billion light years of cosmic history. 2 billion galaxies. But first, the team had to test everything, make sure the instruments were working, calibrate the lenses, fine-tune the spacecraft. And during that testing phase in the autumn of 2023, something unexpected happened. A scientist named Bruno Altieri, he works as the Euclid archive scientist, was looking through some early test images. The images were deliberately blurry, out of focus. They were not supposed to be science images at all, just calibration data, nothing exciting. But Bruno saw something, a faint ring of a light around a galaxy, just a hint, just a whisper of something unusual. He almost ignored it, but something told him to look closer. He looked closer, and what he found was an Einstein ring. Let me explain what an Einstein ring is, because it is one of the most extraordinary phenomena in the entire universe. When a massive object, like a galaxy, sits directly between us and another, more distant galaxy, the gravity of the closer galaxy bends the light from the far galaxy around it, all the way around, in a complete circle, like a cosmic magnifying glass that has accidentally turned itself into a lens. The result is a perfect ring of glowing light surrounding the closer galaxy. And that ring is actually the image of a galaxy millions of light years behind it, stretched into a halo. Albert Einstein himself predicted this effect over 100 years ago. He said gravity bends light. He said if the alignment was perfect, you would see a ring. And he was right. But these rings are so rare, so perfectly aligned, that even finding one is considered a major discovery. Bruno found one in a blurry test image, a test image that was never meant to show anything at all. The galaxy at the center of this ring is called NGC 6505. Astronomers first observed this galaxy back in the 1880s. Over 140 years of looking at it, with every telescope ever built, nobody had ever noticed the ring. It was hiding in plain sight for a century and a half, and Euclid found it in a blurry, unfocused calibration photo before the mission had even officially started. That tells you something about the power of this telescope. Then came November 7th, 2023, the day the first real images were released to the world. ESA Director Josef Aschbacher called them awe-inspiring. Scientists who had spent over a decade building this telescope started crying in press conferences. And when the images went online, the internet stopped. There were 5 images in that first release, each one more staggering than the last. The first showed the Horsehead Nebula, a region of gas and dust in the Orion constellation, about 1/375 light years from Earth, famous for the shape of a horse's head carved into clouds of gas. We have photographed this nebula many times before, but Euclid did something no telescope had ever managed. It captured not just the nebula, but the full field of young stars forming inside the dark clouds around it, in a single image, in sharp, stunning detail, stars being born right in front of us. The second image showed a spiral galaxy called IC 342, nicknamed the Hidden Galaxy, because it sits behind the dust clouds of our own Milky Way, making it incredibly difficult to see. Euclid cut through that dust like it wasn't even there, revealing the spiral arms of IC 342 in a way that had never been possible before. The third image showed an irregular galaxy called NGC 6822, a small, oddly shaped galaxy nearby packed with bright, hot young stars and glowing nebulae. Again, the detail was beyond anything previously captured. The fourth image was a group of interacting galaxies called the Dorado Group, galaxies in the process of merging, colliding, pulling at each other with gravity, leaving trails and shells of stars scattered through space like cosmic wreckage after a traffic accident. You could see the shells of material, the tails curving into space, the scars of billions of years of gravitational violence. And then there was the fifth image, the one that made scientists most excited of all, the Perseus cluster. Perseus is not just a galaxy. Perseus is a galaxy cluster, a gravitational city of galaxies. And it is massive. We're talking about a structure with a mass equivalent to around 650 trillion suns. Inside it, there are thousands of individual galaxies, and it sits about 240 million light years away from Earth. When Euclid photographed Perseus, it did not just see the big, bright galaxies at the center. It saw everything. The tiny, faint, distant background galaxies, the faint wisps of light between the galaxies, the dwarf galaxies at the outskirts of the cluster, and nestled among it all, something nobody expected to see in this kind of detail. Orphan stars. This is where things get truly strange. Stars do not normally float free in space. Stars live inside galaxies. That is just how the universe works. A star is born inside a galaxy, it lives inside that galaxy, it dies inside that galaxy. But the Perseus cluster image showed billions, not millions, not hundreds of millions, billions of stars drifting freely between the galaxies. Stars with no galaxy, no home, no anything. Just floating in the dark, empty void between galactic islands, more than 1,100 billion of them. That is 1.5 trillion orphan stars, all in one cluster, all wandering, all homeless. Scientists from the University of Nottingham, who led the analysis of this discovery, said they were completely surprised by their ability to detect these stars at all, and even more surprised by what they found when they looked at them closely. The orphan stars have a distinctive bluish color. That color tells you something about their age and origin. And when the researchers studied the colors, the positions, and the shapes of how these orphan stars were distributed across Perseus, they came to a stunning conclusion. These stars used to belong to small dwarf galaxies, and they were ripped away. The gravity of the massive Perseus cluster grabbed those small galaxies, tore them apart, and scattered their stars into the void. The stars were not born homeless. They were made homeless by the violence of gravitational forces on a scale almost impossible to comprehend. And here is where it gets even more interesting. Previously, scientists assumed that orphan stars, when they get stripped from their home galaxies, would naturally settle into orbits around the biggest, brightest galaxy at the center of the cluster. Like how a moon orbits a planet. That is what everyone expected. But Euclid showed something different. These orphan stars were not orbiting the biggest galaxy. They were orbiting a point in space between the two most luminous galaxies in the Perseus cluster, a point, not an object, a gravitational midpoint between two giants. Scientists believe this means Perseus recently underwent an enormous merger with another galaxy group. And the collision was so recent, cosmically speaking, that the orphan stars have not yet settled down. They are still circling the gravitational ghost of a merger that happened billions of years ago. The universe is still vibrating from a collision we were never there to witness. Then came May 2024, and Euclid released its first actual scientific papers in 5 new color images. And if the first release stopped the world, this one cracked the ground beneath it. These new images were at minimum 4 times sharper than anything produced by ground-based telescopes. 4 times. And they covered regions of sky so wide that it would take 100 Hubble Space Telescope images to equal just one of Euclid's frames. The team found something extraordinary in the Perseus image they had taken at first glance. 70,000 globular clusters. 70,000. Globular clusters are ancient balls of stars, sometimes containing hundreds of thousands of individual stars, tightly packed together by gravity. They are some of the oldest objects in the universe, relics from the early days of galaxy formation. And in a single image of one galaxy cluster, Euclid identified 70,000 of them. For context, the entire Milky Way galaxy is estimated to have somewhere around 150 to 200 globular clusters. Perseus, in just Euclid's field of view, showed 70,000. Scientists openly said this was beyond their expectations. Then came March 19th, 2025. The day that will be remembered in science history as the moment everything changed. ESA released Euclid's first major data package, the Q1 release, or Quick Data Release 1. And what was inside this data package defies easy description. In just 1 week of observations, 7 days of scanning 3 specific patches of sky, Euclid spotted 26 million galaxies. 26 million galaxies. The farthest of those galaxies is 10.5 billion light years away from Earth. When the light from those galaxies left them and began its journey toward us, our own solar system did not even exist yet. The sun had not formed. Earth was not there. Life was not there. Nothing was there. And yet the light kept traveling across more than 10 billion years of empty space and landed on Euclid's detector. The Q1 data covered an area of sky about as wide as 300 full moons sitting side by side. Inside that area, Euclid classified 380,000 individual galaxies in detail, their shapes, their colors, their distances, their structures, using a combination of artificial intelligence and citizen science. Thousands of regular people around the world volunteered to help scientists look through the images and mark galaxies, lenses, and unusual objects. Humans and machines working together, cataloging the universe. And buried inside all of this, the team found 500 gravitational lens candidates. Remember what we said about Einstein rings? A gravitational lens is the broader family of that phenomenon, where a massive object bends and distorts the light from something behind it. Sometimes you get a ring, sometimes you get an arc, sometimes you get multiple copies of the same galaxy appearing around the lensing object. Each one of these events is rare. Each one is a scientific treasure. Each one tells us about the invisible dark matter sitting between us and the lensed object. Because dark matter, even though we cannot see it, still has gravity, and that gravity bends light just like anything else. Before Euclid, scientists knew of roughly 500 gravitational lens events in total across the entire history of astronomy. Euclid found 500 new ones in a single week. It doubled the total number of known gravitational lenses in human history in 7 days of data. One of the scientists involved put it plainly. He said Euclid found 500 strong gravitational lenses, and that doubles the number we knew about previously. All this, and much more, in just a few days of data. The mission will continue until 2030, and by the end, scientists expect Euclid to have found 100,000 gravitational lens candidates. That is 100 times more than everything we had ever discovered before this telescope existed. And inside those lenses, hidden in the distortions of light, is a map of where the dark matter is, a map of the invisible skeleton of the universe. Because wherever the light bends most, that is where the gravity is strongest. And wherever the gravity is strongest, that is where the dark matter is concentrated. Euclid is not just photographing galaxies, it is photographing the darkness between them, using the light that bends around it as its brush. There is something else in this data that scientists are still working to fully understand. The cosmic web. If you zoom out far enough, and I mean really far, billions of light years out, the universe is not random. It is not a cloud of galaxies scattered like powder. It has structure. Enormous, mind-bending, almost impossible to comprehend structure. Threads of gas and matter stretch between clusters of galaxies like the strands of a spider web. At the intersections, galaxies cluster together in their millions. In the empty spaces between the threads, the voids, there's almost nothing, just darkness. This structure, this web of filaments and voids and nodes, is called the cosmic web, and it is thought to be shaped by dark matter. Dark matter acts as the scaffolding. It forms the threads first, and then the gas and dust and stars fall along those threads, pulled by gravity, building up into galaxy clusters at the intersections. Without dark matter, there would be no web. Without the web, there would be no galaxies. Without galaxies, there would be no stars. Without stars, there would be no planets, no life, no you, no any of this. Dark matter built the universe we live in, and we still have no idea what it actually is. In the deep field south, one of the 3 patches of sky Euclid scanned in its first survey, the telescope observed more than 11 million galaxies. And in that data, scientists found hints, traces, the beginnings of the cosmic web coming into view, threads of large-scale structure barely visible stretching between the clusters of light, hinting at the enormous invisible framework underneath. This field had never been studied by any deep sky survey before. It was completely uncharted territory, and Euclid walked in and started drawing the map. Now, let us talk about what this all means, because numbers are one thing, but the real question is, what does this actually tell us about the universe? Scientists have a standard model of cosmology, a theory about how the universe began, how it expanded, how structures formed, and what it is made of. This model assumes dark energy is a fixed, constant force, always the same strength, everywhere, at all times. It is called the cosmological constant. Einstein actually proposed it back in 1917, and famously called it his greatest blunder, then turned out to be kind of right about it anyway. But here is the problem. As more precise data comes in, from Euclid, from other telescopes, from surveys of the early universe, cracks are beginning to appear in this standard model. Small inconsistencies, places where the predictions do not quite match the observations. Tensions, scientists call them. Places where the universe seems to be behaving slightly differently than the theory says it should. One of these tensions is the Hubble tension, a disagreement between different measurements of how fast the universe is expanding. Different methods give different answers. The more we measure, the bigger the disagreement gets, and nobody can explain why. Euclid was built specifically to help resolve these tensions, to measure the shape of the universe, to trace how dark energy has changed over billions of years, to test whether the cosmological constant is really constant, or whether dark energy has evolved, whether it was stronger or weaker in the past than it is today. Because if dark energy changes over time, that means it is not a constant. And if it is not a constant, our entire model of the universe needs to be rebuilt from the ground up. That is not a small thing. That is not a minor correction. That would be one of the biggest overhauls of scientific understanding in human history. And Euclid is gathering the data to find out. There is something beautiful and also slightly terrifying about all of this. For most of human history, we looked up at the night sky and saw lights, tiny, distant lights. We named them after gods and heroes and animals. We wrote stories about them, we built religions around them, and we assumed, because we are human and we always assume things, that what we could see was most of what existed. Then we invented telescopes, and we discovered that each of those lights was a star. Then we discovered that some of the fuzzy lights were entire galaxies, islands of billions of stars. Then we discovered the universe was expanding, that everything is flying away from everything else. Then we discovered the expansion is accelerating. Something is pushing it faster and faster. Then we discovered that what we can see, all the stars, all the galaxies, all of everything we have ever mapped, is only 5% of what is actually out there. Every step of the way, the universe turned out to be bigger, stranger, and more humbling than we thought. And now Euclid is taking us to the next step, into the 95%, into the dark. In just 1 week of data, it found 26 million galaxies. It found 500 lenses. It found 1.5 trillion orphan stars. It found traces of the cosmic web. It found an Einstein ring hiding in a galaxy we have been looking at since the 1880s. And that was 1 week. 1 week out of a 6-year mission. By 2030, when Euclid completes its survey, scientists estimate it will have mapped 1.5 billion galaxies. 1.5 billion. It will have created the most detailed 3D map of the universe ever produced, stretching back 10 billion years in cosmic history. It will have found 100,000 gravitational lenses. It will have measured the shape of dark matter across 1/3 of the sky. It will have tracked how dark energy has evolved over the age of the universe. And if, when, those measurements come back and they show something that does not match the standard model, then everything changes. Every textbook, every theory, every assumption we have built modern physics on. Gone. Back to the drawing board. Because the universe, as it turns out, is not what we thought it was. That is not a failure. That is the most exciting thing that could possibly happen. There is one more thing I want to leave you with. When Euclid released its first images in November 2023, one of the images showed something in the background that most people scrolled past without thinking about. Behind the foreground galaxy clusters, behind the bright spirals and ellipticals that catch the eye, in the background, so small and so faint that they almost disappear into the noise, there were galaxies, tiny specks of light. Each one of those specks is a galaxy. Each galaxy contains billions of stars. Each star may have planets, and some of those planets, over 10 billion light years away, may have given rise to something that looked up at its own night sky, something that wondered what was out there. And in that moment, when you are looking at a Euclid image and realizing that every pixel of darkness contains history, every speck of light contains worlds, you stop thinking about the universe as a place out there, somewhere beyond, something separate from you. And you start realizing that you are part of it. You are made of those stars. You are built from the 5% of the universe that managed to organize itself into something complex enough to look back and ask questions. And somewhere, drifting alone in the dark between the galaxies, 1.5 trillion orphan stars are still traveling, going nowhere, belonging to nothing, but still burning. Euclid found them, and someday maybe we will understand why they are there. If you made it to the end of this video, thank you. Drop a comment below and tell me which discovery shocked you the most. The Einstein ring? The orphan stars? The 26 million galaxies in a single week? Let me know. Share this video with one person who you think needs to see it, and I will see you in the next one.